What if our planet was cube-shaped? If our planet were in the shape of a cube, everything around us would change profoundly. This structure would directly affect gravity since gravity would no longer be uniform as it is now. The regions along the edges would experience stronger gravitational forces, while the corners would have weaker gravitational pull. This could lead to changes in natural phenomena such as ocean tides, wind patterns, and even climate distribution. From a biological perspective, plant and animal species would have to adapt to the uneven distribution of sunlight and gravity. Trees might grow in entirely different directions, with new structural adaptations, while animals would need to adjust their bodies to cope with varying gravitational forces. Humans, too, would undergo significant changes, affecting health, behavior, and social structures. These effects would not only alter nature but also reshape the way we live and survive. One of the most profound impacts of a cube-shaped Earth would be the alteration of gravity. Currently, Earth's gravity is uniform in all directions, pulling everything toward the planet's center. This uniformity creates stability, allowing natural phenomena to follow predictable patterns. However, with a cube-shaped Earth, gravity would no longer be evenly distributed, significantly influencing both natural phenomena and life on the planet. Gravity on a planet depends on its mass and the distance from a given point to the planet's center. If Earth were a cube, gravity would vary across different regions. Specifically, at the cube's corners, gravity would be stronger because these points are closer to the planet's center than areas along the edges. Conversely, regions near the cube's edges would have weaker gravity since they are farther from the Earth's center. This would create strange changes in how objects move across the planet's surface. Substances like water, air, and even solid objects would no longer follow a stable trajectory, instead of everything falling directly toward the center of the planet as they do now. Objects near the cube's corners would be pulled in different directions, leading to an uneven distribution of gravitational forces. This could result in unusual phenomena, such as water flowing in different directions in various parts of the planet, completely altering natural water currents like rivers and oceans. A noticeable effect would be the transformation of wind patterns and climate. Areas with stronger gravity would tend to pull air masses and clouds closer to the ground, increasing the likelihood of storms and extreme weather events. On the other hand, regions with weaker gravity would have thinner air layers, affecting global air circulation. This could lead to severe climate consequences, altering familiar weather patterns, causing unpredictable seasons, droughts, or sudden heavy rainfall. Most importantly, changes in gravity would have a profound impact on life on the planet. For plants and animals, gravity is a fundamental factor influencing growth and development. Trees, which have adapted to absorbing sunlight and growing toward the light source, would need to adjust their growth patterns. Trees near the cube's corners might grow in unusual directions, becoming denser or growing at odd angles due to stronger gravitational forces. In weaker gravity zones, trees might become taller and thinner because there wouldn't be enough gravitational pull to maintain their usual structure. For animals, changes in gravity would pose significant challenges. They would have to adapt their bodies to accommodate the varying gravitational forces. Species living in regions with stronger gravity would find movement more difficult and might need to develop stronger muscles to maintain normal mobility. On the other hand, animals in areas with weaker gravity might evolve more flexible skeletal structures or move more easily without facing strong gravitational pull. These changes would alter their habits and habitats, leading to shifts in food chains and natural ecosystems. Humans, whose bodies have long adapted to the current gravitational conditions, would also face significant changes. Altered gravity could have serious effects on human health. Those living in regions with stronger gravity might experience body aches due to increased gravitational pull, leading to issues with joints, muscles, and even blood circulation. Conversely, in areas with weaker gravity, the human body could become weaker and more fragile due to the lack of gravitational support in maintaining muscles and bone structure. Moving between regions with different gravitational forces could also be challenging, making travel from one place to another much more complicated. These changes would not only impact individuals but also bring about transformations in societies and civilizations. Industrial activities, construction, and transportation would be significantly affected, as gravity variations would influence how we build structures, move, and produce goods. Maintaining current cities and infrastructure could become extremely difficult with uneven gravity, necessitating a complete reorganization of societal structures and technological advancements. If Earth were shaped like a cube, changes in gravity would have far-reaching and complex consequences. These transformations would affect every aspect of life, from nature to society, creating an entirely new world beyond our imagination. The cubic shape of Earth would have profound effects on climate and weather, causing drastic changes in atmospheric and oceanic currents. Currently, Earth's climate and weather are largely influenced by the even distribution of gravity and the planet's spherical shape. However, if Earth became a cube, the new structural characteristics would alter how natural forces interact, creating a completely different and unpredictable climate system. A cubic Earth would significantly modify air currents, especially wind systems and temperature distribution. The corners of the cube would create extreme climate zones, where temperature distribution would no longer be as even as it is now. Areas near the corners of the planet could become extremely hot or cold because the stronger gravity in these regions would compress the atmosphere closer to the surface, making the air denser, colder at night and hotter during the day. In contrast, regions near the edges of the cube, where gravity is weaker, would experience unique climatic conditions. The thinner air in these areas, free from strong gravitational pressure, could move more freely, generating intense and unpredictable winds. This could result in powerful cyclonic airflow, forming unusual weather patterns such as storms, hurricanes, and sudden heavy rainfall. The global temperature distribution would also change. If Earth had a cubic shape, regions near the corners would receive less sunlight due to the uneven way sunlight would strike the planet. Meanwhile, areas near the edges, where gravity is weaker, would receive more sunlight, creating much hotter regions than others. This temperature distribution would lead to massive ecological shifts. The regions near the corners could become frigid or scorching wastelands with extreme living conditions, while the areas along the edges might develop into tropical zones with intense heat and drought. Such changes would completely alter familiar climate patterns. Variations in temperature distribution would trigger chain reactions in atmospheric currents, disrupting ocean currents. Oceans would no longer circulate as they do now, and warm and cold water flows would shift in different directions, creating areas with significantly higher or lower sea temperatures. This would drastically impact marine ecosystems. Many marine species, which have adapted to stable sea temperatures, would struggle to survive as changing water temperatures and currents disrupt natural food chains. As wind patterns shift, weather phenomena would become increasingly unpredictable. The frequency of storms would likely rise due to strong air pressure differences between various regions. Powerful winds would form in areas where temperature changes are most abrupt. And when they collide, they could generate massive storms far more intense and dangerous than those we currently experience. Areas near the corners of the planet might frequently suffer from blizzards or sandstorms, depending on the climatic conditions of those regions. Rainfall and water distribution on Earth would also be significantly affected. Hotter regions would experience intense water evaporation, leading to the formation of massive clouds. When these clouds move into colder areas, they would result in heavy rainfall or even snowstorms. Water distribution across the planet would become uneven, causing some regions to suffer from severe flooding while others endure prolonged droughts. This imbalance would directly impact ecosystems, agriculture, and the water sources that humans depend on. Additionally, the extreme cold or heat in areas near the corners of the cube-shaped Earth would greatly disrupt ecological patterns. Plant and animal species would have to adapt to new environmental conditions to survive. Many species would migrate to regions with more favorable conditions, leading to major shifts in food chains and ecosystems. The emergence of new species and the extinction of others would likely become part of the adaptation process to this dramatically altered climate. These climatic and weather changes would not only affect nature but also have profound impacts on human life. Agricultural practices, daily activities, and construction methods would need to adapt to extreme weather conditions. Humans would have to adjust their way of living, developing structures and infrastructure to withstand severe weather events and changes in water resources. If Earth were cube-shaped, its climate and weather patterns would undergo profound transformations, creating a world full of surprises and new challenges. These changes would influence every aspect of life, from nature to society, resulting in a planet governed by entirely different rules and characteristics. With Earth in the shape of a cube, its rotation would cause significant changes in how we experience day and night, leading to widespread impacts on the living conditions of animals, plants, and humans. Unlike our current planet, where a relatively uniform rotation ensures a stable cycle of day and night with nearly equal durations worldwide, a cube-shaped Earth would disrupt this balance completely. The planet's rotation would no longer follow a circular path as it does now. But instead, the rotational patterns would vary across different regions. Areas near the corners of the cube would experience extreme effects from this altered rotation, causing unusually long or short cycles of day and night. Specifically, near the cube's corners, the planet's rotation might expose these areas to sunlight for extended periods or plunge them into darkness for unusually long durations, similar to the phenomenon of polar day and night at Earth's poles. In contrast, regions near the cube's edges would experience a vastly different day-night cycle compared to those near the corners. Since gravity would be weaker along the edges, these areas would have much shorter days, with sunlight reaching them for a brief period before quickly giving way to night. This would create drastically different living conditions, forcing lifeforms to adapt to a much shorter day-night cycle than what exists today. These changes could have unpredictable effects on the development and survival of plant and animal species. With an altered day-night cycle, plant life would need to adapt to ensure survival and growth. Plants near the cube's corners, where day and night might last for extended periods, would face unique challenges. Some plant species might evolve to maximize photosynthesis during prolonged daylight hours, developing more efficient ways to absorb energy. However, in areas where the night lasts abnormally long, these plants would have to adjust their growth cycles, possibly by slowing down metabolic activities during extended darkness to conserve energy. Conversely, in areas near the edges of the planet, where day and night cycles are shorter, plants would need to modify their photosynthesis mechanisms to maximize the brief periods of sunlight. Plants in these regions might evolve to grow rapidly and efficiently convert light into energy during daylight hours while also developing resilience to survive the short, sunless nights. This would lead to the emergence of unique plant species capable of fast growth, rapid regeneration, and adaptation to constant environmental changes. Animals would also need to adapt to the differing day and night cycles. Species living near the corners of the planet would face abnormally long days and nights. These animals might develop special survival habits and physiological traits to cope with prolonged darkness or excessive light exposure. For example, some species could evolve unique sleep or hunting patterns suited to extended day-night cycles, employing strategies to evade predators or find food. In particular, animals near the extreme poles of the cube might need to alter their metabolism to survive the long, cold nights or endure the prolonged heat of extended daylight. In regions near the planet's edges, where the day-night cycle is shorter, animals would also have to adjust their behavior. Predators and foraging species would need to take advantage of the brief daylight hours, adapting their internal clocks to the shortened cycle. This could lead to the evolution of fast-moving, highly efficient animals that can complete their daily activities within a very limited time frame. With such drastic changes in the day-night cycle, humans would also experience significant shifts in their daily lives. Activities such as agriculture, industry, transportation, and household routines would need to be adjusted to accommodate the constantly changing light conditions. Domesticated animals would have to adapt to new rhythms, creating challenges in maintaining stable ecosystems. Humans would need to modify their work and rest schedules to align with fluctuating light conditions, potentially leading to the development of new infrastructure and technologies to maintain a stable living environment despite prolonged days or nights. With a cube-shaped Earth, the uniformity of day and night would no longer exist, creating vastly different living conditions for animals, plants, and humans. This transformation would require all life forms to adapt and develop new survival mechanisms in a world where day and night no longer follow the predictable patterns of the past. If Earth were to take on a cube shape, the changes in terrain and tectonic activity would create distinctive geographical formations, completely altering the landscape of the planet. Currently, Earth's spherical shape allows for the relatively even distribution of geographical features such as mountains, valleys, plains, and deserts. However, in a cubic world, the corners and edges of the planet would have a major influence on terrain formation, leading to drastic shifts in land structure and distribution. The corners of the planet would become particularly extreme zones, where tectonic forces generate towering mountain ranges or deep chasms. These regions would experience intense gravitational variations combined with irregular planetary rotation. In areas near the corners, where gravity is stronger, the pressure beneath the surface would be much greater, leading to the formation of massive mountain ranges. These could resemble colossal rock formations rising from the Earth's crust, created over millions of years through powerful seismic activity. Such mountains could be similar to the ones found in Earth's polar regions but on an even grander scale. In addition to towering mountains, the corners of a cubic Earth might also give rise to deep chasms, where extreme underground pressure carves out vast sinkholes or limestone valleys. These areas could become deep, shadowy voids where sunlight rarely reaches, fostering unique ecosystems that may support strange and unfamiliar life forms. The depths of these valleys could be among the most extreme environments on the planet, with incredibly dry and cold conditions, presenting significant challenges for survival while also offering extraordinary geological diversity. In the regions near the edges of the cubic planet, where gravity is weaker, geographical formations will develop differently. These areas will tend to evolve into vast plains or expansive deserts, featuring flat landscapes with minimal geological activity. The uneven distribution of gravity will create regions less affected by tectonic processes, where the land is less compressed or uplifted. These plains will become extensive lands with flat terrain, suitable for agriculture but also susceptible to harsh climates, potentially forming vast deserts with scarce water sources and minimal life. These deserts could expand significantly in areas near the edges, where water scarcity and arid conditions will create vast expanses of endless sand dunes. The climate in these regions will be extremely harsh, with drastic temperature fluctuations between day and night. During the day, the sun will scorch the land, generating extreme heat, while at night, temperatures could plummet dramatically, creating an immense thermal contrast. These deserts will be home to unique animal and plant species capable of withstanding these harsh conditions. Animals will need to develop rapid movement abilities and exceptional water-finding skills, while plants will evolve special mechanisms to retain moisture and protect themselves from the intense heat. The vast plains near the edges of the planet will provide favorable conditions for agricultural activities but will also face challenges in sustaining life due to the arid soil. These plains could become the cradle of great civilizations, yet they will also struggle with climate change and water scarcity. However, they will have certain advantages, such as a more temperate climate, flat terrain, and strong potential for natural resource development. The regions located between the edges and the corners of the planet will experience dramatic changes in geographical formations, creating complex and diverse landscapes. These areas will feature a combination of mountains, valleys, plains, and deserts, forming regions with highly varied terrain and rich geological diversity. Such environments will support a wide range of ecosystems, where animals and plants will need to develop diverse survival strategies to adapt. The transformation of Earth into a cubic shape will result in an extraordinarily unique and complex landscape. The corners and edges of the planet will give rise to towering mountains, deep chasms, vast plains, and deserts, making the planetary scenery more diverse and abundant than ever. These changes will create a vastly different living environment for animals, plants, and humans, requiring all life forms to adapt to a new world with harsh and challenging natural conditions. When Earth transforms into a cubic shape, not only will the planet's physical structure change, but there will also be widespread disruptions in the living environment for animals and plants. Key factors such as climate, gravity, day-night cycles, and geographic distribution will be entirely altered, presenting new challenges never before encountered by life on this planet. This will demand that species evolve new survival mechanisms, particularly those accustomed to current climate and gravitational conditions. One of the most noticeable changes will be the alteration of gravity. In Earth's current spherical shape, gravity is evenly distributed and directed toward the planet's center. However, with a cubic form, gravity will no longer be uniform across all regions. Areas near the corners of the planet will experience significantly stronger gravitational forces, while regions near the edges will have weaker gravity. This will greatly affect animals and plants, especially those adapted to the current gravitational environment. For animals, changes in gravity will make movement more difficult. Species living near the corners of the planet will endure stronger gravitational forces, requiring their bodies to develop special adaptations to withstand or compensate for this gravity. Animals in these regions may evolve stronger muscles to facilitate movement or alter their body structure to prevent being compressed by the intense gravitational pull. In contrast, in areas near the edges where gravity is weaker, animals might struggle with balance issues, leading them to develop lighter movement patterns or enhanced flexibility to maintain their ability to hunt and survive. For plants, changes in gravity will also pose significant challenges. Trees will have to develop new physiological mechanisms to endure or adapt to uneven gravity. Those living near the corners of the planet, where gravity is stronger, will need to develop deeper and sturdier root systems to anchor themselves against the intense gravitational pull. Their leaves may become broader and more rigid to withstand the strong gravitational force, while their photosynthesis process may need to adjust to maximize sunlight absorption during the irregularly long day cycles. In contrast, plants in regions near the edges, where gravity is weaker, will grow differently. Trees here may develop slender trunks, allowing them to grow taller without being weighed down by strong gravity. However, these plants might struggle with stability in the soil since their root systems won't be as robust as those found near the corners. To survive in these challenging conditions, plants might develop specialized survival strategies, such as producing drought-resistant seeds or adapting to extreme climatic conditions. The Earth's cube-shaped form would also bring significant climate changes, directly impacting life on the planet. Regions near the corners could experience extreme cold or heat, depending on how sunlight reaches each area. The altered day-night cycle would create extremely harsh climate conditions, forcing species to adapt or change their survival strategies. Animals and plants in these regions would have to develop resilience to extreme temperatures or mechanisms to conserve energy during prolonged daylight or darkness. Animals living near the planetary poles would need to adjust their hunting and food-seeking strategies. They might develop specialized survival skills to find food during long summers or hibernate through extended nights to protect themselves from harsh environmental conditions. Plants in these areas would have to adapt to prolonged sunlight exposure or its absence, developing protective features against extreme cold or scorching heat. Conversely, in regions near the edges, where dry climates and extreme lighting conditions prevail, plants would have to evolve robust drought-resistant mechanisms. Trees in these areas might need to store water efficiently or develop deep root systems to access underground water sources. Animals in these regions would require quick movement and efficient foraging strategies to survive in arid environments. Predators and herbivores alike would need to adapt to brief daylight periods when food sources are most accessible. Environmental changes would not only present challenges to existing species but also create opportunities for new species to emerge. Those capable of rapid adaptation would thrive in newly formed habitats. These species might develop traits suited to uneven gravity and harsh climates, potentially becoming dominant in the new world. However, species unable to adapt in time would face extinction, leading to drastic shifts in global ecosystems. Ultimately, if Earth were shaped like a cube, life on the planet would undergo monumental transformations. Animals and plants would need to develop new physiological mechanisms to adapt to gravity variations, extreme climates, and altered ecological conditions. Species with strong adaptability would survive, while others would struggle and potentially face extinction. This would result in a complete restructuring of ecosystems and the planet's living landscapes. If Earth took on a cubic form, every aspect of life would change dramatically. Uneven gravity, extreme climates, and irregular day-night cycles would create immense challenges for living organisms. Both animals and plants would need to develop new survival mechanisms to cope with the drastic environmental changes. Humans, too, would struggle to adapt to inconsistent gravity and extreme weather conditions, requiring changes in lifestyle, food sourcing, and survival strategies. Regions near the corners would endure extreme temperature fluctuations, while areas near the edges would face arid climates, significantly affecting ecosystem distribution. Overall, life on Earth would no longer resemble what it is today, and both humans and other species would have to adapt, or face the risk of extinction. The cube-shaped Earth would usher in a new era where every aspect of life must change to adapt to a drastically different world. From gravity to climate, from day and night cycles to living organisms, nothing would remain as we know it. This transformation would not only pose immense challenges for the survival of all species but also demand that humanity find creative solutions and adapt rapidly. Reflecting on this, we can grasp the fragility of life and its deep dependence on the surrounding environment. It compels us to ask, do we possess the capability and perseverance to overcome the challenges that such a different world would present? Can we sustain long-term development, not just for humanity but for all living beings on this planet? Another crucial question arises in our minds. If Earth were to change tomorrow, would we know how to protect life? Or would we stand on the brink of extinction due to our inability to adapt? The answer may not lie in technology or current knowledge, but in our ability to perceive and adjust the way we live.